So today we'll try to do a top-down web service using the Java J2EE technology platform. Earlier in our sessions we have seen a bottom-up web service related details. So what we started right now is Eclipse, and we'll use this environment to, we already have a pre-built WSDL which is available. That's something which is available whenever you go for a top-down approach. That's an approach which assumes that you have a WSDL or your service definition files, and you are trying to use the same to write your to write your web services. In this manner we will be actually generating a good amount of code, and since this code is generated on the server side, that's why you will be calling this as the skeleton code. So let's go ahead and create a dynamic web project. I'll call it as top-down WS. Choose the implementation web module version to 2.5. Next, and finish. What it creates, if you see on the left hand side, is a bare minimum project structure, J2EE project structure. No specific details has been put in yet. We'll now paste our WSDL file which is available into at the WebINF level, and then we will use that WSDL file to generate some skeleton code, and in that code itself basically it will create some utility code so that we don't have to write all the networking and other communication and SOAP related details that we typically have to if we don't use the access container based feature. So in this case again Eclipse will use the access capability to read your XML and auto generate a good amount of classes. That classes needs to be available here, and out of those classes there are certain places where you will have to, or where you are expected to write your logic. So we are now just going to the location where we have the WSDL file available. Let's copy that WSDL file and paste it in the place here. I've already shown you in the previous sessions that there are many open source files which are available, which you can also use it to do that. In fact, let's do that one thing rather than doing this one which is local. Let's try to write something which is already available through the internet. So this is the URL. We'll go and you will see that this is a internet URL. Now you can see that this is the internet URL where the stock code service is located. This is some site web service.next thing which is there. We will try to just do a Control A. Let's go back. Okay. Let's try to see the sites which is available here. You can see this is the place where it is available. If you click on stock code, it gives you the detail here. And this is the location of the WSDL thing. So copy that, paste it up, Now, Eclipse is not that advanced enough, but if you use other IDEs like your RAD or JDeveloper, you can actually just specify the URL and it will fetch the WSDL. In this case, we will have to basically copy those details. Go here, right click, new. I could have used that simple file, the WSDL which was available, but we just want to make sure that it's something which it uses here. So a real-time WSDL file. So once you have copied the WSDL content in your stock.wsdl file, right click on your source, new, other, go to your web services, choose the web service, and by default you will see that it will choose bottom up. Change the selection to top down, and then it gives you the option to browse to the location where your test is available, where your service is available. So our service is available in the top down WS thing. We'll choose this particular file and then do a OK. We'll just put a publish also on the same, and monitor also, no issues on this one. Next, next, and it asks you to do the start of the server since it wants to publish things. So what it will do is it will take your WSDL, it will auto generate a bunch of classes which we'll see in a while, and it will deploy that service. So you will have to write your logic there. Do a next. Next. Behind the scene, you can see in the background it is starting up the server, and just do a finish. So now if you see, it actually created this .NET and all, because that was something which was there in the WSDL. So since we used an external component just to experiment ourselves, at the lib level you have all the access jars added up. This we have seen earlier. Even for your bottom up it gets added, because that's what Eclipse provided, an inbuilt support for access web service container, and it uses the same to run that particular detail. In your source folder, it creates the same package name which was earlier here as a namespace. If you go up, whatever the namespace which was available, it just tries to use the same to create that particular thing. This was their net w web service x www. It's in the reverse manner it has created the thing here. Take a good look at the number of classes. So this is what we call it as the auto generated thing that it gets done. So it tries to create a good amount of auto generated classes for us. These are all collectively called as skeleton classes. Now you don't have to go into and understand, because this is all will change if you switch from access container to some inbuilt containers like WebSphere web service engine. If you are using IBM products or Oracle WebLogic engine, they have their own web service engine. Access is the most common one, so that's what it creates. You should just browse around. Stock code here is just an interface. Now those of you who are at least 5-6 years back, those who have seen a traditional way of writing web services will be familiar that you have to have an interface and all those things that used to be there in the EJP word when you used to do a remote communication. So herein also in Java way of writing your service provider, all of this gets generated. So that's where you have the service locator and all. Internally all of that will be filled with access classes. What your access is doing here is that it is taking care of the entire responsibility of conversion from SOAP XML into your Java object and vice versa. So the marshalling and unmarshalling capability is taken care by these classes. This is where it puts SOAP specific thing, because get code, that was the method which was available, corresponding to which this you have a equivalent method coming up here. This get code, if you look into the WSDL, you should have a message. If I go into the design or in the binding, if you come down, you should see, you can see get code as the operation. So corresponding to operation, you have the individual interface with the method. That's what we have learned, that all the interfaces becomes methods, or interface is a set of methods. So whatever you have specified in WSDL, that's what getting converted. IMPL, this is the class where we are expected to write our logic. That is why it is appended with the suffix IMPL. Skeleton stuff, these are all pre-generated, all underscore code and basic access related API. It will be hard for you to remember each and everything. This is pre-generated code, so that's something which is not even intended for you to put in. If you open the file declaration, it puts in also. This is all auto-generated. You change WSDL, this code will change. So at your IMPL level, you are expected to write your logic. In this case, we will just try to suppose return anytime if we get a quote value, we will just add suppose 50 to that value, 50 plus, and then the whatever the symbol which we have passed as an input. Again, we are not focusing here on some very complex logic, just a simple, we wanted to check that the logic is implemented. But we know that this is where you will use your API thing. At this level, you can actually call any Spring class or Pojo, which in turn can call any JDBC thing, and the entire framework will be there. But the purpose here is that if a call comes to this level, you can do all that middle tier stuff on the DAO layer. But once the data comes, you need to return things. Now if we deploy this code, because we have just updated the IMPL file, so we'll have to deploy it again. So right click. The best way is to restart your server, or you can publish it also again. I think there is a publish option also available. Since we restarted, it should take the change. Now the way we tested earlier thing, use this whatever the WSDL file which is in the WSDL folder, because this is what it locally created. Remember that when you copied your WSDL from this thing WSDL, the port name which it is trying to type is still your internet names, but since it is getting implemented locally, so you have to open, or you have to use the local WSDL, and in this case you will see local hosts for those individual stuffs coming in. Although it puts in there, you can see here that this is the only service which it is implementing right now. No, this SOAP 12 and all those hypothetical things that service used to do. This particular implementation is implementing this thing only, stock code SOAP. So right click, web service, run with Web Service Explorer. Configure the same. Click on this particular part, stock code SOAP, get code. If you put in, does it take any symbol or what? Suppose we put FB and then we do a go. You can see it gives you the data here, 50 plus FB. This means that our implementation class was invoked, and whatever the output that came out of it was there. If you click here, let's go down, you can actually open your TCP IP monitor to take a good detail, but if you click on the source and just double it, you will see here the details of your the same thing in SOAP message structure also becomes visible. So here if we went into as a input, and as a result you added output to it. Now looking at this, you can tell that this is SOAP 1.1 because that's what SOAP env is trying to point out to. And if you increase your TCP IP, if you try to see that, just enable headers and change the byte to XML, you will get the same level of detail. HTTP OK, which means that there is a right output that is coming in. So again, there is no fundamental difference, and again I don't want to discuss a lot of theory around it, because if you see it, you believe it in a more better way rather than just having lots of theoretical discussion. This is the top-down approach. You start with a WSDL where your service definition is written. That's something typically which comes out of your design phase as an output, and then you give it to the developer folks or application development team to come out with the implementation. And what we saw was how to auto-generate some of the classes, helper classes, and then how to write the logic in the intended classes. And since Eclipse usage uses its access inbuilt access capability, and it tries to use that to pre-generate all this class, and it deploys the same. We have deployed the same on the Tomcat server as a hosting environment, but different architectures, IBM suite or Oracle suite, will have different combination, and your code which will get generated will differ depending upon what web service container you use. We are using the access web container, and this is the code that it generates as long as you use the access container. So thanks for at least attending this session. We'll continue now with some other topics. We will now write a client to this running a web service which we just now created earlier. Now in real times, now we will be using the same workspace to create the client, but as we know that in real time you might be having the web service running somewhere else, and you will just create a client to it. We could do that, like for this service, the stock code service which is running at this location, we can create a client and connect to this remotely also, but we'll try to see and connect the same. So let's try to write a client for a running web service, because you do both the roles, a web service provider role which we just now saw in both modes, your bottom up approach wherein you have a code and you expose it, or you create a WSDL and expose it as a service, or the other way around where you have a WSDL and you create a code and write all your logic into it. So to generate a client, again you go with that same approach. Go ahead, create a dynamic web project. We will see here as put here as RPC. This is called as RPC client. So I'll put here as RPC client. Put it as 2.5. Next, finish. It creates a dynamic web project here. Now let's try to be a client to an external web service which is running in, because locally if we do, it might look a bit simpler itself, but we already have this web service running. This service is at some location. You can see that it's some .NET based service which people have, or some provider has created. We know that in web services, if I am a client, I don't need to worry about whether it's a .NET provider or a J2EE provider. I can choose any technology to write my client. So this is a good case here for cross platform technologies. Now the service provider has written .NET based service, and we will be using J2EE to write a client to it. This WSDL is already copied here in one of our previous projects which we just now did. I simply copy pasted this WSDL. So let's reuse the same, this stock.WSDL. I'll just copy it again and paste it here. If you open it, it's simply a copy paste of what you get in this particular URL. I just simply copy it and paste it into a stock.wsdl file. So create a stock.wsdl file and just paste it here. Now let's use this XML to create a RPC client. Now in case of an RPC, when you try to act as a client, you still generate some auto generated code the way we did it for a service provider in RPC in a top down manner. So as a client also, we will feed this WSDL to the client generation API which your Eclipse provided through the integrated access service model, and will pre-generate some classes. We will leverage those classes to write our logic. So we'll do a right click on that particular thing, the WSDL web service. You can see it gives you an option of generate client. It chooses that option, do a next and finish. If you now go and open that source folder, you will see that it has created a bunch of classes for you now. These all classes are generated in the client code. Stock code, all these things, these were generated based off the WSDL which you showed. So as we talked about that, the code generated will differ depending upon the runtime engine which you are using in. Herein we are trying to use the Axis engine, and this is the code that it generates. So we'll now use some of these classes to write our client. So in this package itself, now I can create a different package as well, but let's use this package. Next, and this select this package, do a new, have a class, and then we will put test client. So in this case, it done at the client level does not generate any pre-built class for you. You will have to write it from scratch. The only thing that we'll be leveraging here is that these pre-built classes which it generated. Now I have a sample client code written. We will use that to modify this same. Again, it will give you this error, but we'll just do the parallel modifications. Take a look. First, we'll have to create something which is the SOAP binding stub. What is the name of our SOAP binding stub? The one that ends with stub. It is stock quote SOAP stub. So we'll try to leverage that, copy that class and paste it here. Paste it here as well. So we'll basically created a stock quote stub reference, then we are instantiating it. URL we'll have to import. Okay, first it tries to look for something which ends with the service locator. So the name of the one that we have is stock quote service locator. So we will use that. Remember, all I'm trying to do is leverage the classes which have been generated for us, pre-built generate for us. So stock quote locator is what it calls as. If you click on it, it will ask you to import the URL java.net, and all these access fault, malfunction URL, and your remote exception needs to be added up. Now then the only thing which gets meaning, let's check it out. Catch this one, and then we need one more, I think. Yeah. So now you see that the only error it gives is error. Now this is, we know that it's a pre-built stuff, so delete that part and do a control space to see what are the methods which are available. Now this was get quotes, so somewhere it should have available that get quote should be available. You can see get quote is available, and in this one let's try to send a bad performing stock, that is the Facebook thing. Now what does this particular returns? Let's try to see this particular method. If we look into it, it tries to return a string itself. So I'll put here as string data type. And remember, all I just don't know what is the logic which the service provider has done. All I got was the WSDL, and that's what you will also face through in real time. And based on that, I copy pasted the WSDL in my project, auto generated the stub classes, and now I'm trying to write a client to connect to it. So it gives some string to me, and I'll put here better variable name stock result. This is what we want to publish. Now if everything has gone good, and if it is able to connect, it should be able to connect to that particular service and all. If you try to run it now, just do a right click, run as Java application. You'll see it will give you an issue. The issue will be some connection related stuff, connection refused. So whenever you get that, you should put in that this URL which we are pointing to is definitely needs to be changed, because this URL should be the same where your service is located. So this is this particular URL which is located in the WSDL thing. So we want to have this get code soap thing. So I'll copy this URL and paste it here. Now we'll try to run it. Right click on this thing as Java application. You can see it gives you live result of that service. It gives you an entire XML here. Stock quote is Facebook. This is the price, date, time, change, open, a good amount of detail itself. So this is the way you will write a real-time client. That's what we wrote, a real-time client for a .NET hosted web service on internet. Tries to at least go on this site. There are many other services which are available here. If you go, apart from stock quote, you have currency converter, global weather, London gold and silver fixing. All these things are available. You can choose any one of them. You now know, you just have to have the WSDL, add it into a XML file, generate the pre-built classes, and then write it based on this particular logic. You're able to see the data which is coming in. So this is a way of using your JAX RPC API to generate or act as a client itself on service provider. We have a .NET service hosted on internet, and we connected it using a client.